Hello, everyone. This is David Larson with the Realizing Improvement Through Team Empowerment program. Today's topic is developing knowledge through testing. This is one of the most important concepts in quality improvement, so we're going to spend a little extra time on this. As we discussed last time, we've now moved from the left side of the A3, where we focused on defining our goals and understanding the problem in the current state, to the right side, where we'll now focus on developing solutions. At the beginning, we told you to not jump ahead to solutions, but now that you better understand the problem, the time has come to go ahead and design solutions to the problem. Before we start, we need to remind ourselves that the way work gets done in any business or enterprise is through processes. A process takes some kind of input and applies people working in facilities using specific tools and methods to create some kind of output. There are millions of processes of all kinds that are used every day throughout the world. Dr. Paul Batalden has said that every process is perfectly designed to get the results that it gets. Now, the process is not necessarily designed to get the results that you want, and in fact, it may not even be designed at all. The process produces what the process produces, whether it's good or bad, or whether the results are consistent or inconsistent. The resulting product or service is only as good as the process that produced it. And remember, no design is itself a design, and it's usually a bad design. So if you want different results, you must change the process. In other words, you must design and implement a better process. Last time we introduced you to the key driver diagram. As we discussed, key drivers are the few things that must be in place or must happen on a consistent basis for us to achieve our goal. In other words, they represent intermediate goals, and the interventions or countermeasures are the solutions or the specific methods or other changes that will help us achieve those goals. Since the only way we can improve our results is by improving our processes, then our interventions usually are changes to those processes, be they changes in skill, techniques, procedures, machinery, or technology or other tools, or facility layout and design. These combination of changes represent our new process design. Okay, so now it's time to talk about how we go about redesigning a process. As we do, we need to recognize some important realities of designing solutions in real life. First, it's important to recognize that there are usually many ways to accomplish a goal, and some ways often are better than others, depending on what exactly you're hoping to achieve. Second, things rarely work in real life exactly as they were originally envisioned. Actually, that's not quite right, so let me correct that. Things never work exactly as they were originally envisioned. Third, things that work well in one setting do not automatically work well in another setting. Therefore, even solutions that have been shown to work elsewhere usually have to be adapted to local conditions. So what do you call the discipline of designing solutions that work in the real world? That's engineering. That means you're going to need to be able to solve problems like an engineer, which means you'll need to be able to think like an engineer. So how do engineers think? Engineers use what's called the engineering design process. The engineering design process in some ways resembles its cousin, the scientific method, but there are some key differences. The main difference is that the purpose of a science project is to answer a question, whereas the purpose of an engineering project is to solve a problem. Most of us are very familiar with the scientific method. It's a method that's proven its worth billions of times over. But believe it or not, the engineering design process is even older. Instead of starting with a question, it starts with a problem. The first step is to define the problem. Then we do our background research and we frame the problem in terms of the objectives we're trying to accomplish, what resources we have available, and any constraints that may apply. Then we start to design a solution by thinking of a number of different possible solutions, not knowing yet for certain whether or not they'll work. We then start to develop and prototype the most promising solutions, and then test our prototypes. We then evaluate the results, modify the design, develop a new prototype, test, again review the data or results. And as we do that, we gain greater understanding of the problem we're trying to solve, what works and what doesn't, and why. We repeat this cycle until we have a solution that works well and a thorough understanding of how and why our solutions work. This is what we mean by developing knowledge through testing. Our understanding of why the solutions work or don't work is even more important in many ways than the solutions themselves. So let's take an example. You're an engineer in the Middle Ages and have been hired to help build a state-of-the-art medieval castle in your city. You're hired to be the project engineer after construction is already underway, with scaffolding now in place and the castle walls climbing. Your job is to figure out how to better move the 2.5-ton stones to the top of the 30-foot wall. The current process is that the crew wheels the stones on a cart up the scaffolding. This has worked reasonably well most of the time, except sometimes the stones break the cart, and occasionally the cart rolls back and injures someone. Plus, it takes a lot of work and a lot of wood to build a scaffolding that will support the weight, which gets more expensive and more dangerous as the walls get higher. The line boss comes along and sees you thinking. You're overthinking this, he says. You just need to be firm with the workers. You just need to let them know who's boss. Otherwise, they'll walk all over you. Watch, he says. And then he proceeds to go talk to the crew. Hey everyone, listen up, he yells. We need you to work harder, but we also need you to work smarter. He then tells them that they will be instituting bonuses for meeting production targets if there are no injuries. He then has one of the workers put up signs around the site that say, "Safety is number one," and "Let's finish the project on time and on budget." 3 days later, a cart carrying a stone comes loose, destroying part of the scaffolding. Fortunately, no one was injured, but you ask your boss if you can try a different approach, and he allows you to give it a go. He's been meaning to take a vacation anyway. As the boss leaves you in charge for a couple of weeks, you realize that you're going to need to make real changes, not just tell the workers to work harder or work smarter. You fix the scaffolding, take down the signs, and look to see what real process changes you can make. So you start to put together your key driver diagram. Your key driver in this case is that you need to get the stone to the top of the wall safely and efficiently. You've already tried one intervention, telling people to work harder, and realize it's not a great solution, so you cross that one off. You go out to the workplace and talk to the workers. The first one you meet says, "I'm so glad someone is finally listening to us. We've been saying for years that we need more people." He describes how exhausting the work is, and if they just had more people to push and pull the cart, you'd be fine. So you add more workers to the key driver diagram as a possible solution and test it. When you do, you find that it's hard for more workers to find a place to push and pull. Plus, it's awkward to fit everyone on the scaffolding. And at one point, one of the workers is pushed off of the scaffolding. Fortunately, he's okay, but you realize that this just isn't a viable solution, and you need to look for another. You gather together the group of workers around the A3 and ask them to brainstorm possible ideas of other solutions to try. You come up with a list that includes the following. Have the workers lift the stones up the scaffolding. Use a donkey to pull the stones on the cart. Build an earthen ramp to the top of the wall. Use a catapult to launch the stones to the top of the wall. Pull the stones up with a rope. You test all of these ideas. You find that lifting the stones up the scaffolding is even more dangerous and requires more people than the cart, so you cross that one off. You try every donkey at the site, but none of them will set foot on the scaffolding, so you cross that off. You start to build an earthen ramp, but quickly realize it will be too messy and too labor-intensive, so you cross that off. You have a lot of fun testing your catapult with watermelons, but you realize pretty quickly it would be quite dangerous with stones, so you cross that off. Notice you've already learned a lot about things that don't work well. You're already developing knowledge, valuable knowledge, which you shouldn't discount. Next, you use a rope to pull the watermelon up to the top of the wall. It works, but it keeps bumping into the wall. Plus, the watermelon weighs much less than the stone, and you realize you would need 10 workers to all be pulling from the top of the wall, which is too crowded. But it gets you and the team thinking. You may actually be onto something here. So you gather your team again together to brainstorm how you might better use the rope to bring up the stones. You come up with another list that includes 3 more ideas of how you might use the rope. You could use the rope to pull the cart, swing the stones up to the top of the wall, or hoist the stones from a tower. You use a rope to pull the cart, and it helps, but it doesn't really solve the problem of needing to build an expensive scaffolding, nor does it make things much safer, so you cross that off. You build a swing and have a lot of fun swinging watermelons to the top of the wall, but you realize it would be too unmanageable for stones, so you cross that off. You construct a tower and pull a watermelon up. This works pretty well, but you wouldn't be able to fit enough people at the top of the tower to pull it up. So your team thinks about it further. One of the workers says, "What about attaching a pulley?" You try that and it works. You can pull the watermelon to the top of the tower while keeping the workers who are pulling the rope on the ground. You then try it with a wooden block, and that works. You then try it with a stone, but it breaks the cantilever beam. So you install a larger beam, and that works. You call this apparatus a crane. But it doesn't work perfectly. You can move the stone up and down, but you can't move the stone over from the side of the wall to the top of the wall. You keep thinking with your group. One idea is to swing the stones from the crane to the other parts of the wall, but you quickly remember your experience swinging the watermelon and realize that won't work. Another idea is to build another set of scaffolding at the top and cart the stones horizontally once you get them to the top. You try that, but quickly realize that it's going to require a lot of heavy scaffolding. Another worker says, what if we put wheels on the crane and put the whole thing on rails? You test it out on a small scale with wooden blocks, and then with a stone, and it works. You then build a full-size mobile gantry crane and start hoisting stones to the top of the wall. You soon find that you can triple the rate at which you can move the stones, with much less scaffolding required and in a much safer way. This puts you ahead of schedule and on budget. You step back to reflect on all you've learned, not only about construction, but about the process for designing good solutions. You realize that you need to define the problem, generate a number of alternative solutions, develop prototypes, and then test, and test again. But each time you test, you need to learn. It's not just throwing things against the wall to see what sticks. It's about gaining a better understanding of how things work and using that knowledge to design better and better solutions as your understanding increases. The method you used to gain knowledge was that you started with an idea to test. You then planned your test, you did your test, you studied or checked the results, and then you acted on the results. By acting on the results, I mean to say that you either adapted or modified the solution and tried it again, you abandoned the solution to try a different one, or you adopted and implemented the solution, or some combination of the three. As we've learned before, this is known as the plan, do, study, act cycle, or the plan, do, check, act cycle. Every time you see PDSA or PDCA, you should think small test of change. By conducting multiple tests of change, you have gained knowledge. This is often described as a PDSA ramp, where we start with hunches, theories, and best practices, which by themselves would lead to poorly designed solutions. As we conduct tests, we gather evidence and data, and learn and refine our solutions until we gain firm knowledge through testing, which allows us to master the thousands of details we need to understand in order to create a well-designed solution. There are a few more points that are important to emphasize here. First, when a team member comes up with a solution that we don't think will work, but we don't know for sure, we should adopt the motto of, all right, let's try it. Be very quick to run a test to see if you can learn something from the idea. At the same time, we should assume that no solution will work until proven otherwise. In other words, every solution must be tested, no matter how confident we are it will work, before it is implemented. Once we've decided to try it, we should start on a small scale, and start right away. We shouldn't wait until next week or next month if we can help it. We should try something this week, maybe even today. And as we do this, we can't be afraid to fail. In quality improvement, you will have many failures. That's a guarantee. It's not a question of whether there will be failures, but only how and when you will fail. Failure is another way of saying you're learning what doesn't work. What I say to my team is we need to fail fast, fail small, and fail friendly. In other words, we should get our failures over with as quickly as possible, on as small scale as possible, and with people who will forgive the failures that are occurring during testing so that we can learn from all of these failures. All right, so we've come to the end of this important session. Just a few key summary points. First, to improve an outcome, you must change the process. If you do not change the process, you will not change the outcome. This means that you'll need to change something about the techniques, tools, facilities, or personnel skill, and almost always it will be a combination of changes. So you need to use these to create a good design. Second, you should be aware of three realities of designing solutions in real life. There are usually many ways to accomplish a goal. Things never work exactly as they were originally envisioned, and things that work well in one setting do not automatically work well in another setting. Third, start by brainstorming a number of possible interventions to support your driver. Don't just list one solution at a time. List several possible solutions in the order that you want to test them, recognizing your best ideas may not work, so you can quickly move to testing your next ideas. Fourth, once you have possible solutions, you need to hypothesize, test, refine, hypothesize, test, refine, hypothesize, test, refine, and so forth, increasing your understanding as you go. This is known as the PDSA or PDCA cycle, and it's what allows you to gain the knowledge that you need to design great solutions. And finally, do not be afraid to fail. It's a paradoxical truth that we must experience failure in order to succeed. Or, more accurately, we must learn from failure to gain the knowledge we need to be successful. Now, this can be emotionally tough, so we should support each other through this process, encouraging each other to keep trying until we get it right. Thank you for watching. This is David Larson with the Realizing Improvement Through Team Empowerment program.